the math like formula booklets. So there's AA and AI.
Good strategy.
Okay, sure. And then I need to open Paint.
Thank you, Git. By the way, a Q&A means that you guys come to us with questions.
Oh my goodness.
Okay. What's
this?
your favorite math topic? I think you know the answer, Lipid.
Okay, in theory, I should now do that.
Oh. Definitely not calc.
Okay.
I'm
gonna hope everyone can see Microsoft Paint being shared.
Yep, absolutely beautiful.
Great. Okay, I will keep going for as long as I am humanly able to, and then Andrew will share his thing if he wants to. But yeah, I will try my best to write out working and stuff as I go. Everyone can see this, yes? The scribble that I've just drawn.
About a ruler, I'm not sure though, because it has an entire sine curve on it. So not sure that would be legal.
Also, I guess I should clarify that when I took IB, well, okay, first of all, Andrew didn't even take IB.
Yeah, that's why I'm like, no need for disclaimer. You have a totally unqualified person here.
So, Andrew didn't take IB, but he likes to. He's a nerd when it comes to high school math syllabi. So he will know stuff. I, however, took math in IB before AA and AI existed. So I don't actually have a good idea of what's in each syllabus or how it's split up. No, I didn't take further math. But I will try to help regardless. Okay. I guess I'll just look in the revision stage chat for questions.
Yeah.
And oh my gosh, why are there so many?
Yep. Start out with. Also, all right. Same question several times.
I mean, I saw SpongeBob, but SpongeBob.
Send all of your questions in.
Questions. Do I start with those vectors questions, or are those the same ones that you just?
The second and third one are the same.
Oh, okay, right. You're just collecting them from me. Got it. Okay. Suppose let's go through these. So, 3 points, A, B, and C lie on a plane. Fine. Actually, these are extremely long. Do you want me to go through everything here, or is there a specific part you wanted me to do?
All right. Let me do my. I'm just gonna quickly look at this. All right. So A is kindergarten. B is also kind of kindergarten. C is a bit less kindergarten, and D is hopefully not kindergarten. So there we go.
Yeah.
The problem is that you cannot get to D if you don't do A, B, and C. So
Okay. C and D are the confusing ones.
definitely time for you to show off your MS Paint skills, Creative.
Oh gosh. I mean, so do I have to work through what is like V lies on L? So I need the plane by 3.
All right, so they're trying to go for point up. Oh, okay. Interesting.
Okay, I guess let's just go through it and see how I do. So this one, so if I want to find the vector AB, this would just be the point of the vector B minus the point of vector A, which should just be -3, -2, 0, right? And then A, C is the same thing, but with this, so you get
All right, I forgot that's how IB does vectors, the notation.
Oh, is it?
Wait,
is
also,
the convention the other way? I don't know.
Also, Creative, that would be -2, 1, and -7.
Negative.
For
Oh,
AC.
yeah, other way. Yeah, right. Right, so that's that.
2 more.
Sorry, what?
That's 2 marks already, maybe 3.
Oh, 2 marks. Right. Okay. Then hence find the equation of pi1, which is the plane that these define, expressing your answer in the form ax plus by plus c z equals d. Okay. Well, the way I would do this is you basically want to find the normal vector for this, because this equation is of the form ABC dot x y, oh gosh, yc is equal to d, where this thing is your normal vector, or yeah, just normal vector. So the way you can find the normal vector is by taking the cross product of 2 vectors in the plane, and you know 2 vectors in the plane because you just found them. So I don't want to take the cross product of these. Oh gosh. Okay, let's do this. So cross -2, 1, -7 equals. So this term would be 14 minus 0. This term would be 0 minus 21. This term would be 3 minus 4. Is that right, Andrew?
3 minus, hold up, -3 minus 4.
Yes, correct. Thank you.
Yeah, this is why I hate linear algebra.
Great. So now we have our normal vector, which means we can then put it into this form.
Yeah, sorry, Creative, for the interruption.
Yeah.
The formula for cross product can be found in your formula booklet. You should memorize by now.
I guess it's worth explaining how I did this, because there is a pattern to it. So if I have one vector like this, and of course cross product like only really makes sense in 3 dimensions, so it'll always look like this. So the way I do it is for the first one, suppose I want this term, right?
Oh, they call it vector product. Never mind.
Then I ignore the first row, and then I look at the product of these two minus the product of these two. So actually, let me color this like this. So here it would be this minus this. So this form would be like this minus this. So then if I then want the middle term, then I ignore the middle row, and then I pretend that this row starts here. So I have like this term is brought down here. There's one down here as well, and then I do the same pattern. So it's this minus this. Does that kind of make sense? So if you look at what I've done here, I've done like -2 minus 7 minus 1 times 0. That's where 14 minus 0 comes from. Here I did 0 times -2 minus -3 times -7. So that's where 0 minus 21 came from. And so on and so forth. Okay. Anyway, there's also a formula that Andrew posted. So just use that. Like you don't need to memorize this. So I'm going to delete. Oh gosh. Is that why? Yeah, okay. So anyway, now you have a normal vector. So if you remember, this form of the equation of a plane just takes x, y, and z to be any point in the plane. So let's just take one that's easy. Let's take A. So I'll just denote it like this. So the vector of A dotted with n. I mean, order doesn't matter here because dot product is commutative. So we have 3, 0, 0 dotted with 14 minus 21 minus 7. And this is going to be equal to 42. And that's your D. And then this thing will, this vector gives you your A, B, and C. So your final equation would then look like 14x plus, oh, no, minus 21y minus 7z equals 42. God, these questions are so long.
What do you mean long?
My brain is just, I need to warm up, okay? Oh, wait, the plane pi2 has an equation. Okay, so they've given you the equation of another plane, which is great. The line L is the intersection of the two planes. Verify that the vector equation of L can be written as that. Right. The way
all right, so there's a question. Can we use any of the points they give us to take D? Yes.
Yes. Correct. So I mean, you can probably verify this yourself, but just to go through it quickly, if I chose B, for example, the answer would be -2 times minus 21, which would also give me 42. And I'm sure the same would be the case if I took C. So it is fine to take any point in the plane. What is the strategy for this, Andrew? I feel like it's just taking the dot product of the normals, but is that wrong? My intuition is telling me that may not be right.
Well, I mean, you can just test it out, right?
I don't want to take another cross product and have it be wrong.
Hold
Although
up.
I feel like it has to be, right? There's no way it's not.
Hold up, I'm doing mental math right now, which is not the best option, but we go with it. 33 negative 1 dot 3. Wait. It lies. Let's think about this out loud, shall we? So it lies in the intersection of pi 1 and pi 2. That means it lies on pi 1 and it lies on pi 2. That means that it is perpendicular to the normal of the first guy and the normal of the second guy. So in theory, you should take. Wait, or you can just
Actually,
take 1, 1, negative 1, and then dot it with the normal factor of each plane, and then to show that
oh yeah,
0,
that also
negative 2,
works.
0 lies on
Yeah.
pi 2 as well.
Right. So if I just take the dot product of this with the normals and show that that's equal to 0, then that should
Yeah.
be fine. Okay, let me write this. So D. So first of all, 0 and minus 2, 0 is the point B. So that's like fine
Just,
as it is.
wait. Hold up.
Yeah.
All right. Someone said that for part B, you just literally verify. Oh yeah, true. You can just take the equation for R, and you put it into you assume the intersection and whatnot, and you show that it's indeed equal to 2. Like you would say R equals lambda, negative 2 plus lambda, negative lambda, plug it into
Right.
pi 2.
Yeah. I feel like
And if it's equal to 2, then you're good to go.
I mean, I feel like what you said was shorter, but let me do both. So
very high tariff of 2 marks.
Yeah, because it's only 2 marks, which is why I'm like, there's no way there's that much work, right? But I don't know. Let's just do both. So this dotted with our normal vector from here, so that's 14 minus 21 minus 7 is gonna be, yeah, I mean that looks like 0. And then this dotted with the plane that they gave, which will give us a vector of 3 minus 1 and 2, is also just going to be 0. So that means, I guess you also have to verify that 0 bytes to 0 lies on this plane in this method. So if you just plug that in, you get that minus minus 2 equals 2, in which case you verify what you need to. So that should be sufficient. The other method is to just plug in this into what you plug it into both, right? You have to show that it's a member of both, which looks like more work than this. So I guess I mean what method you actually use doesn't matter. So let's just do it. So let me just rewrite this. So x is equal to lambda, y is equal to minus 2 plus lambda, and z is equal to minus lambda, right? So when you plug this into x minus 21y minus 7z equals 42, you get 14 lambda minus plus 42 minus 21 lambda plus 7 lambda equals 42, which is true. And then the plane that they give, 3x minus y 2z is equal to 2. So if you plug in the same values for x, y, and z, what you get is 3 lambda plus 2 minus 2, no, minus lambda. I'm doing too much mental math at once. Minus 2 lambda equals 2, which is also correct. Okay, I kind of went through that in a very wishy-washy way. Is what I did clear? I can explain it if that wasn't clear, because I'm kind of just like going through the work by myself.
It's kind of like finding intersection between a line and a plane. Except that in this case, it doesn't matter what lambda is, because as an intersection, every single lambda would work. AKA, it lies on the plane already.
Okay. I don't see anyone writing anything, so let's move on to part 3. So the plane pi3 is given by a different equation. The line L and the plane pi3 intersect at point P. Show that at the point P, lambda equals 3/4, and hence finds the coordinates of P. Okay.
Why is this question so weird?
Why?
Like, I can't really see what they're trying to do here. Okay. Yeah, sorry, carry on.
No, I'm just trying to remember how to find the intersection between the line and the plane.
Exactly what you just did. But in this case, we get a lambda. So you would put pi, -2 plus pi, and negative pi into pi3 to get the value of lambda.
Wait, why? You have pi's here instead of lambda? What are you talking about?
No. Exactly what you did, right? So you would put identical, but instead of getting identity, you would find the value of lambda. That's the difference. Because it's not true for all lambda. It's only true for one lambda.
Yeah, I have this equation.
Yeah.
Oh, right, I plugged this in. Yeah, I get what you mean now. Okay, so the equation that I've given, I should write this down. 2x minus 2z equals 3. I take these and plug it into this, which then gives me 2 lambda minus minus 2 lambda.
I mean, the answer is given. Great.
3. Huh? I mean, yeah, that's why I laugh, because then this gives me lambda equals 3/4. And then now that you know that lambda is 3/4, then you can just plug that in to this equation and you just get the point, right? So you get R is equal to, that was awful, 0 minus 2, 0 plus 3/4 times 1, 1 minus 1, which gives you the vector 3/4 minus 5/4 minus 3/4.
Yes, we hate fractions for the record.
Okay, so that should be part C. And I remember the person that asked this was unclear on part C, so I hope that was clear. Okay, great. Let's do part D now. The point B lies on L.
Okay.
Find the reflection of point B in the plane pi3. Right. Okay.
This
one's not
feels
too
so
bad.
random. This feels very random. You have two planes, they intersect at a line, they intersect that line, they intersect a different plane. So basically, in part D, you use none of the stuff from A, B, and C because the question line is already given. So I'm like, wait,
Oh
what?
gosh. Okay, so the way I would do this, right? You have oh gosh, where's my cursor? Part D. So what you want to find here is the like, okay, so you have some plane,
Mm-hmm.
you have the point B, and your plane has like some normal vector.
Yeah.
You can use like the distance from any, you can take a vector to B from the plane, you dot it with the normal vector, and that'll give you a vector that looks like this, right? Which, if you subtract that twice,
Mm-hmm.
you'll get your reflected point, right? That would be my strategy here.
Yeah.
Does that kind of make sense? So the normal vector for this plane, like, remember, we have this equation, so I will copy this down here. From this, again, similar to before, we just get that the normal vector of this plane is equal to 2, 0, minus 2, right? Like that is sufficient as a normal vector. So if we then want a normal vector to the point B, then what we would do is take, let's just take, what's a point that lies on pi 3? Oh, we have a,
which is intersection.
Yeah, so we have this point which lies on pi 3. I'm gonna rewrite this actually as 1/4 of 3 minus 5 and 3. So if we take, okay, let's also normalize this vector, so we have a unit normal vector. I don't know if this is a long-winded method, but that's just...
That is very long-winded. I don't think you need to do that at all.
I mean, then how do you know that the distance of your vector is actually correct?
Crossing your fingers.
What do you mean, Andrew?
All right. First off, I'm gonna re-sketch this so people have a better idea of what we're trying to do.
Okay, sure.
So I'm gonna keep screen sharing. I'm just gonna send a screenshot in the chat.
Okay, sure.
So, where is it? Where's the chat again? So essentially, this is what they're asking us to do. We have a line. The plane is going to be pi 3, right? We know the line L passes 2 points, B and P. Point P lies on pi 3. The question is, you now want to reflect line L over the plane pi 3. What is the line that you're looking for? And I marked it with D because that's what part D is all about. So to do that, you need to get 2 points. You need to get B prime and you need to get P. How do we get B prime? Getting B prime is just a matter of finding the image of B over the plane. AKA, you can find a distance between point B and the plane.
Mm-hmm.
Then, you can find the intersection of that line perpendicular to plane pi 3 and passing through B. That point is gonna be the midpoint of B prime. And from there, we can find B prime.
Is that different to my method?
No, it's not different, but it's clearer because you didn't put point P on it. So it's like you can take any point, sure, but the thing is, the end point is you want to get the line. You want to get a mirror image, right?
Mhm.
So might as well use point P that they made you find the part C.
Right. Yeah, sure. Okay, so we'll use point C. I'm gonna rewrite my unit normal thing because that's how you find distance. Is this clear to everyone, like why I'm taking a unit vector here? So if I take a unit vector and I take the dot product of that with the vector from P to B, then I get the vertical distance of B from the plane, right? And that only works if my normal vector is a unit vector. So,
Sir, I don't think that's a unit vector.
is it not?
The magnitude of 1, 0, -1 is √2.
Yeah, it's 1 over √2 times that then.
Oh, never mind. My bad.
Andrew.
My bad. My
Okay.
bad. My bad. My bad.
Actually, before I write this, let me find what this vector is. So I want to go from B to this vector. So I can just take, let's do the other way. So I'll start with 1/4 of, this is a minus sign. Oops. 3 minus 5 minus 3. And then I'll subtract B, which is 0 minus 2, 0, I think. Yeah. Which then gives me
What do you have 104 again?
Just to make it cleaner.
Oh.
Anyway, I think that's right. So now I have.
Excuse me?
I hate how you're so judgy about every line of work that I'm doing.
No, but honestly, sorry, Gradiv, but I think we're better off just find the intersection of a line perpendicular to pi3 passing through B, because that would be easier for people to follow instead of trying to find a distance. You know what I mean?
Okay, sure. How would you? So you just start from B and you set the same normal.
Yeah.
vector
So
as your-
let's
Okay,
say that
fine.
the intersection of perpendicular to pi. Or you know, I think it might be easier for me to share my screen.
Oh yeah,
But
sure, go for it.
Yeah. So, yeah, no, this is fine. Okay. Pull it up. Patash. Voila. So I should be sharing my screen right now.
Yeah.
What we're saying, what I should say basically is, let's say the intersection is, I don't know, I, for instance. We know that the line passing I and B would be perpendicular to the plane pi3. The normal vector is also perpendicular to plane pi3. It's also perpendicular to the plane itself. Therefore, the direction vector of the line passing through B and I is gonna be the coordinate of point B plus, I don't know, T times the normal vector of N3. So the normal vector of N3, that is, wait, what would that would be 2, 0, -2. The point B, we know it is 0, -2, and 0. From there, we can find the coordinates of I, because I is simply the intersection of the line and pi3. Identical to what we did before. We know the equation of pi3 is 2x minus 2z is equal to 3. X is 2t. Y is negative 2. Z is negative 2t. At equals 3. T is equal to 3 over 4. Oh, sorry, 3 over 8. If T is 3 over 8, the intersection I, that's going to be 0, negative 2, 0, plus 3/8 times the normal factor. So that would give you negative 3 over 4, negative 2, and negative 3 over 4. That would give you point I. Now, we know that point B is 0, negative 2, 0. And point I is negative 3/4, 3/4, negative 2, negative 3/4. B prime we can just double the coordinates of I and then minus the coordinates of B, or do whatever you want to get B prime. So that would be negative 3/2, negative 2, and negative 3/2. So that's D1. D1, so all they're asking you to do is find the reflection of point B. Now, we know where B prime is. We know where P is. P, wait, creative, what do we get for P again?
Huh? Oh, we got 3/4, negative 5/4, negative 3/4.
3/4, negative 5/4. And what?
A negative 3/4.
Negative 3/4. Thank you. How do we define a line? Passing a point and direction vector. Direction vector, that's gonna be 3/4 minus 3/2, negative 5/4, sorry, minus negative 2, negative 3/4 minus negative 3/2. Oh, that would give you 9 over 4, 3 over 4, 3 over 4. So therefore, the equation of a line that you're looking for is let's use a different letter. S. Et voilà. Does the reflection lay on the plane pi 3? No, it acts as a mirror. Any other questions? How do you do D2? All right, so a line is defined by 2 points. We know P lies on the plane rather bad, so we know the image of L is going to pass point P. Following so far? We also just found B prime from D1. That's the image of B in the plane pi 3. From there, you can easily write down the equation of a line simply because you have 2 points and you're done. You know where B prime is, you know where P is. The direction vector, well, how do you find the direction vector of a line passing 2 points? That's just going to be BB prime. That's just gonna be B prime P, right? So that's it. You have a point. Doesn't matter which point you choose, and you have a direction. All right. Can we move on to the second question? Yo, creative.
Hi. Yes.
Yes, let's move on.
Yeah. That's. Oh, I thought you were gonna move on.
Oh wait, what you want me to take question 2 as well, or?
I mean, okay, I can take it.
Okay.
Where is it? Where is it? Is it the one that was just posted?
No. Hold up.
Like the one posted by SpongeBob.
Wait.
I mean,
Did
there's
anyone?
also
Yeah.
there's also hold on, let me share my screen. There's also this one, which was posted a while ago.
Oh yeah. That's why I just reposted.
Oh, okay, right. Should we go through this one first?
Yeah.
Okay, sure. Also, in the meantime, I was writing out like my working for part D, which I got this thing. I don't know if that's what you got, but I can go through this if you don't want. Considering the vectors A and B such that what? Okay.
I love this question.
Interesting. So for A, okay, let's start with A down here. So let me let's I'll write the working for it here, but let's try and visualize it on the right. So A is some vector that goes like 12 and -5. So it will be like somewhere here-ish, right? That'll be for vector A. And vector B is some vector which has an absolute value of 15 or magnitude of 15. Let's quickly calculate the absolute value of this. So magnitude of A would be square root of 5 squared plus 12 squared, which is that 13?
Yes.
Okay. So the way to visualize what this question is asking is that you have a vector of length 13, and the vector B has length 15, but it can be in any direction. So you have a circle that looks like that of possible values of A plus B. And then you measure distance from the origin, right? So if this is your center of the circle, and this is where you're measuring distance from, it should be kind of clear that this vector is the smallest possible vector you can get, and this vector is the largest possible vector you can get, right? And it should also be clear that in this case, the absolute value of A plus B would just be the difference of their absolute values, which would be 2. And in this case, the maximum value you can take would be the sum of their magnitudes, so that would be 28. And of course, across all these vectors, it can take any value in between those. So you know that 2 is the minimum value. And then the maximum value is 28. I hope that's correct.
That makes sense to me.
Okay. So for part B, let's take a read. Given that a plus b is a minimum, find p, where p is the vector a plus b. So, okay, fine. If it's the minimum, you know it must be this case, in which case, since it lies along the same line, you should be, like, you know the magnitude of this vector is 2, but it points in the exact opposite direction as a, and a has length 13. So p would just be equal to minus 2 over 13 times a. I think that should be sufficient. Do I have to write this out, or I think that. Can I go over how I got that again? Yeah, sure. So I know that this case where the vector points opposite of a and has magnitude 2 is the case when a plus b is at a minimum. Does that make sense? Because the reason why is because you need to, like, if you imagine measuring distances to points on this circle from a point that's like off the center, then the point that would be closest is the one that's directly opposite you from the center of the circle. Right? So you know that this case happens when a and b are collinear. And when, or like share the same span or whatever. When this is the case, your resultant vector of a plus b points opposite to a and with a magnitude of 2. So you have, so you know that the vector itself will be like 2 over 13 a vectors, but it points in the opposite direction, so you also need a minus sign. This is 2 marks, so I don't really think you need anything involved for this. I think if you just articulate that line of reasoning, you should be fine.
To be fair, that line of reasoning, to be fair, that line of reasoning is worth way more than 2 marks.
Well, I don't think you need to write all of that down. I think you can just reason that.
Yeah, but let's be realistic. Like for a lot of students, they're just gonna move on. There are bigger fish to catch.
Yeah. Okay. If that didn't make sense, just ping me. I'll explain it again. I'll do part C for now. So consider the vector q such that q is anything.
This
Find q. Huh?
This part should be the most straightforward, I would say.
I haven't even read it yet. Find q such that the absolute value of q equals the absolute value of b, which is given as 15, and q is perpendicular to a. What?
2 equations, 2 unknowns.
Why is this 5 marks?
2 equations, 2 unknowns. 1 mark for recognizing that. 1 mark for actually getting the 2 equations. 2 marks for solving.
Why do you? Why would you? No. Okay, wait, Andrew. I'm going to explain my line of reasoning, right?
Yeah.
So if you want a perpendicular vector to a, right? Then I can have A1 perpendicular is equal to like -5 -12 just by taking this and swapping it and doing a minus sign to one of them, right? Right?
You sure that's the one?
And I can get the second one by doing the other way, so this would give me like 5 12,
Ah.
right? Like these are the two
This is,
perpendicular vectors
by
that
the way, for the record, people, I'm pretty sure this is in the alternative methods.
this is, I mean, I don't see why this is 5 marks.
No, like the algebraic way I just tested, that's definitely 5 marks.
Okay, I don't even know what algebraic method you're. Oh, do you literally write out like square root of x squared plus y squared and write some?
No, I would just do x squared plus y squared equals 225. And then whatever
and then
a is
okay,
multiplied by,
fine.
yeah,
Jesus.
that'll be 5 marks.
Yeah, I wouldn't do that because so this would give you these
Yeah,
are
that
two
would give you a rise
perpendicular
right away.
vectors. And
No.
you know that the magnitudes of these are the same as A because you just rotated A. Oops.
But
So,
we know Q has same magnitude as B, so we have to scale it up, but pretty much.
So Q, I mean, there's two solutions, right? So Q can either be 15/13
Yeah.
of A1 perpendicular, or Q2 can just be like literally the same thing. I'm not gonna write it out, but yeah.
And of course, noticing that x and y have to be positive real numbers, only A2 makes sense. Sorry, only A2 perpendicular makes sense.
Oh, I didn't even read that. You're right. Right. There's a tiny plus here, which means you reject this one. Thanks, Andrew. Okay, I guess let's go to the next weird vectors question that they posted. Lots of vectors today, eh?
Do we have another vectors? Oh, wait. No, I don't think that's... I think a couple questions were sent before that. Hold up.
Oh, there were?
Yeah.
Oh, right, yeah.
I'm gonna dig it and then hold up.
Okay, sure. Let's do those first. Do you mind taking do you mind taking the job of giving me questions or like keeping
Of
track
course.
questions, and then I'll just face them. Okay.
Wait,
thanks.
yeah.
I can't even. Oh gosh.
Oh God. Oh, wait. See the one I'm... You know what? I'm just gonna copy paste the image if it makes it easier for you. Oh, you got
Actually,
it.
I think I got it.
Yeah,
I'm
you got
guessing
it.
I have to do that. I have to do that for both. So let me get the other half.
To be fair, when I see this question on the exam, I'm actually surprised.
Why is this 10 marks? Oh gosh.
No, I'm surprised.
Okay.
Yeah, surprised that they make you do a lot of no scaffolding, just one part as is. This is on the SL paper as well. 10 marks, and I'm like, all right.
Okay.
And now people say AI and AISL are out of the same level. Like, I'm sorry, but AI doesn't do this ever.
Right. Okay. Okay,
And
let's
friend.
see. So consider the functions f of x equals 1 over x minus 4 plus 1 and g of x equals x minus 3. The following diagram shows the graphs. The graphs of f and g intersect at point A and B. Find the. Do I need the coordinates of B?
Yes.
Okay,
That's
let's find them. So, uh, do I have to do this? Can I just like reason? How many marks is this even? It's probably not
5.
that much. What's this? What's this line?
What do you mean?
This line is x equals y equals 1, right?
Wait, you sure that it will be the midpoint?
It should be rotationally symmetric, right? So I can just go this way. I don't really want to
Like,
do.
I can see what you're trying to do, but I'm like,
So that means this is x equals 4, right? Because x minus 3 equals 1 for this,
so
which
what?
means
I'm just gonna
this
do it
should
in my head.
be
So x
5,
minus 4.
2. Is that correct? I'm doing
What's
such
like?
bullshit right here.
Wait, the coordinate of
I think
line.
that's correct.
Hold up. X minus 4. X minus 4. X minus 4 squared equal to 1. X minus 4. That's equal plus minus 1. Minus 1 plus 1. That's gonna be 5. Yes, 5 2. Yeah, that works. That works.
That's so funny. This is
Reluctantly,
totally
I
not.
have to admit it works.
This is totally not what they want you to do for this. Okay.
How?
Um.
Ignore what Gradov's just done.
Yeah.
Just do
Okay.
it.
Wait, Andrew. Can you just explain what you have done? Because I.
Bruh, that's like, anyway, I should stop saying kindergarten. So
I'll stop sharing
I'm
this.
just gonna
You
type it
can.
out.
Oh, okay, sure.
Minus 1 is equal
That
to
is
x.
so funny to me that worked.
Wait, what's the function again? Plus 1? Yeah, okay. Equals x minus 3. Then just solve the thing. So that will give you x minus 4 squared is equal to 1. Or x minus 4 is equal to plus minus 1. Or
Oh yeah, that is
x equals
pretty
5.
easy.
Or
Y x minus 3. G of x is x minus 3.
because
G of
yeah,
x is
because
defined up here. So you equate these two.
oh my, implies. Wait, no. This should be IMF.
Yeah, I think that looks fine. So
Yeah, that's
you would get x equals 3 and x equals 5 as solutions. You have the x equals 3 solution, so you take x equals 5. You plug that in, you get y equals 2, so that gives you your point B. I can explain what the fuck I did, but you shouldn't use what I did in an exam.
yeah. Most likely you have to prove it before you use it, but we have to prove it. It's not work, and it defeats the purpose. Oh,
Well, do you have to prove it? This function is like translationally odd anyway. Like that's fine.
translationally odd. Uh,
Like
anyway,
it's odd
just
about this.
on.
Okay, yeah. Just ignore what I did. Okay, in the following diagram, the shaded. What is the shaded region? Enclosed by the graph FG, the x-axis, and the line K. So this region.
Yeah,
Okay. Find the area of the shaded region. Oh wait, no. The area of the shaded region can be written as log p plus 8. Find the value of k and the value of p.
10 marks.
Is that interesting? Okay, sure. So I mean, the way you're meant to do this is probably integrating this.
Sorry,
One,
Gradov.
no?
The way you're meant to do this section, this question B, That to me is some sort of foreshadowing
Foreshadowing of what?
that you're gonna do something a bit shady.
Wait, what do you mean by that?
The way you're supposed to do section B, the way you're supposed to do part B.
Okay, now I don't want to attempt this because I'm gonna pull some bullshit again. I feel. What is the way I'm supposed to do this, Andrew?
No, no, I'm just messing with you. Like you were just trying to find this area, right? So splitting up into two parts, the triangle and
Yeah, I mean, okay. Like, is it wrong to take the area from here to here and then the area from here to here? Like, is that not correct?
I don't know if you have any more interesting tricks up your sleeve. That's what I was referring to.
Okay. What we expect you to say, like, oh, this area is like a mirror of this area, and so I can find.
Yeah, exactly. I'm prepared for that.
No, I'm not gonna do that. So okay, let's do this. So we know what A and B are, right? So let's call this shade. What's a good name for this shaded region? Give me a Greek letter, Andrew. Let's go with this one. I don't remember what this character is, but let's go with that Greek letter. So that represents the area is equal to, so the integral from here to here of x minus 3, and we know what those points are. It's from 3 to 5. Plus the integral from 5 up until k of, what's the function number? 1 over x minus 4 plus 1, I think. Right, so if we write this out, let me see if I remember how to integrate. This will be x squared over 2 minus 3x from 3 to 5 plus log x minus 4 plus x from 5 to k. Oh gosh, I'm at the end of the page. Okay. Math. So 5 squared minus 3 squared is, oh, probably 4 squared, right? And then you take half of that, so that could be 8.
Yeah.
Minus 3 times 2 is 6.
3 times 5 plus 3 times 3, that's negative. Yeah.
Log of, well, okay, you have to replace this with k, so let me just write that out first. Minus log of 5 minus 4 is log of 1, which is 0, minus 5.
All right, creative. Sorry for interruption. So
yeah.
some people in the chat was suggesting that we should have found the area of a triangle instead of taking the integral. Well, I mean, either way would take you the same amount of time, right? I know it would be a bit faster if you do a triangle, but honestly, an hour and a half. I mean,
again, that's probably just completely fine to do. So if you notice that, go for it.
Yes, you are more than welcome to do it.
You know that the thing is, what are the coordinates of this again? Yeah, so it has a length of 2 and a height of 2. So you know that this is just going to be an area of 2. So you don't need to do this whole 8 minus 6 BS that I've done, but it's totally up to you. It gives you the same thing anyway. So let's combine like terms. So 2 minus 5 plus k, so you'll get k minus 3 plus ln k minus 4, right? And you know this must take the form log p plus 8, which means this thing must be equal to 8, which implies k is equal to 11, which then implies that, well, let's just plug it in. Ln of 11 minus 4, which would give me 7 plus 8. So p is equal to 7.
And ladies and gentlemen, that was a 10-mark question.
Yeah, it's awful lot of marks for this.
To be fair, whenever logarithms are involved, marks are awarded very generously. That's what I've noticed.
That's fair, yeah.
Because you will get 1 mark just by recognizing, oh, you can add logs together.
Mm-hmm. Okay, let's draw line, and then let's keep going. What's the next question, Andrew?
Hold up. Let me just go back and dig.
All right.
And wait, did I miss something? Nope. Copy image, paste, voila.
What the fuck is that? Oh no. Okay.
Oh, there's a question. My God, I swear to God, every single time we do a Q&A, this shows up.
Do I have to do all of this? Okay, fuck it. The acceleration a of a particle moving in a horizontal line at time t is given by, sure, where v is the particle's velocity. And v is greater than minus 1. Okay, sure. At t equals 0, the particle is fixed at origin O and has initial velocity v0. By solving an appropriate differential equation, show that the particle's velocity at time t is given by this monstrosity. Okay, so let's. First thing to remember, right? Let me write down a. I don't like that the question is question A and the acceleration is A. Okay, so let's recall that A is given by the time derivative of velocity. So this is dv by dt. And we're given an equation of this form. So we can write dv by dt equals minus 1 minus v. And this looks separable, I think.
It is indeed separable.
What you would do to, I assume you want to solve this, right? Yeah, by solving an appropriate differential equation. So actually, let me factorize it like they did. So you have minus 1 plus v. So let's just do integral of 1 over 1 plus v dv equals minus integral of just dt. This will give you I think that's right. Plus some constant, which, oh wait, no, this is okay. So, okay, sure. So let's say that it's plus some constant here, right? When I rearrange this to give me 1 plus v equals something, I can rewrite this as like a constant, probably, right? Are you guys familiar with this? like the plus c, I can bring into this constant as a factor.
Yeah, can you do it step by step?
Sorry, what?
Can you do it step by step, like taking exponential of the right hand side, and
Oh, okay, sure.
Yeah.
So I'll write it out like this. So e to the minus t plus c equals e to the minus t times e to the c, and you just
Yep.
take this as a. So a is just like some constant from integration, but it turns out
Voila.
to end up as a factor, right? And so
Perfect. Thanks,
this gives
creative.
you an explicit function of v as is explicit v as a function of time. Minus 1. You also know that at t equals 0, v is equal to a minus 1 by plugging it in here, and this has to be equal to v naught, right? Which then implies that a is equal to v naught plus 1. So plugging this back in, this gives you v is equal to 1 plus v naught e to the minus t minus 1. And that should be the form that they have over here. Did that make sense? Cool. Let's go to part B. Initially at the origin, the particle moves in the positive direction until it reaches its maximum displacement from O. The particle then returns to O. Let S meters represent the particle's displacement from O to S max, its maximum displacement from O. Part 1 is, okay, let's write this out. So I'm really not built to do calculus, Andrew. Part 1, show that the time capital T taken for the particle to reach S max satisfies the equation that thingy. Okay. I'm honestly not that. Why does it? Oh, I see why. Okay, fine. So, okay. So, what you would expect? Let's get some intuition for what's happening here. So, if I have a curve that looks like this, right? I know that it's going to be a negative exponential, so it'll look something like that. But it has this, it's 1 times a negative negative exponential plus this factor of v naught, which can be like anything, right? But you're starting from this anyway. So at t equals 0, you expect to start at some velocity v naught, and you have this negative exponential looking thing which will go like this, and it'll reach some eventual whatever, right? If I consider what the displacement graph of what this would look like, it starts out with a positive velocity, but then it reaches at some point 0 velocity, and then reaches like a negative velocity, right? And so you would expect at some point it reaches something where this point would be S max, and this corresponds with where this thing is equal to 0. So the person who wrote it in the channel, that is correct. So S max corresponds with v equals 0. So you're solving for when this thing is equal to 0, which I think should make some sense. So let's copy this and put it here. and set this equal to 0. So I have e to the minus t, or I guess in this case capital T, right? Because that's how they've defined the time unit for like the time corresponding with S max. So e to the minus t equals 1 over 1 plus v naught. You can take the reciprocal of both sides. So this will give you e to the capital T equals 1 plus v naught. Was that step clear? Is it clear why reciprocal means removing the minus sign? And this is the result that we require, so that should be fine. Ping me if that wasn't clear. I'm gonna move on. By solving an appropriate differential equation, why? And using the result from part BI, find the expression for S max in terms of. Yeah, of course we would. So let's do this. So next thing to remember is that displacement is the time derivative of velocity. So let's do that. And then what we know is, what do we know? Find the expression for S max in terms of v naught. Okay. Wait, how are you meant to set up a differential equation with this?
Point up, what's the question?
Is it literally just using this? Do they just want you to integrate this? Because that's kind of stupid. Okay, so we have this expression, right, of v in terms of t, and the rest are just constants, right? Like 1 is, oh shit, sorry, 1 is a constant, v naught is a constant. So if we write, oh shit, this is, what have I done here? ds by dt is v. You guys didn't see that at all. Okay, so we have ds by dt is equal to this expression. So 1 plus v naught e to the minus t minus 1. This again looks separable, so s should just be the integral. Do they have a? I guess not. So it'll be from 0 to whatever time variable you care about of 1 plus v naught e to the minus t minus 1 dt. So integrating this, you would get 1 plus v naught minus e to the minus t minus t from 0 to capital T, which would then give you 1 plus v naught 1 minus e to the minus capital T minus capital T. I think. I hope that's correct. Are you following, Andrew?
0 to t. That makes sense. Yeah.
Okay, so this is like, this s is the function of t. I then now want an expression of s max in terms of v naught. Okay, I guess this implies that capital T, so the t that corresponds with s max, is given by log of 1 plus v naught. So if I plug that in, S max is going to be 1 plus v naught, 1 minus e to the minus log of 1 plus v naught minus log of 1 plus v naught. So you now have S max in terms of just v naught, which I can't be asked to simplify. But I think that's correct. Okay, I'm gonna move on. Let's do C. Oh wait, no, that's still part of C. So let v t minus k represent the particle's velocity k seconds before it reaches S max. So yeah, that's fine. This is just the formula we saw before. By using the results to part B, part 1, show that vt minus k equals e to the k minus 1. Right. So they want us to use this result. They want us to show what v of t minus k is that. Okay. Let's copy this thing and bring it down here. And let's copy this thing and bring it down here. So what we have is, so capital T, which is the time corresponding with S max minus k. If we plug that in, we get that, which should be equal to I'll write it like this: e to the k over e to the t minus 1. We plug this thing in here, and this is going to cancel with this. So you get e to the k minus 1, which is I think what they wanted. Yeah. Is that clear? Again, I'm just going to truck on. So I'm relying on you to ping me and ask me to repeat stuff if it wasn't clear. Okay, so to use a similar expression for t plus k, that should be simple enough. You would basically just copy this working, but just put pluses instead of the minuses, right? So you would do t plus k, which would turn into t plus k, which would just, it should basically give you e to the minus k minus 1, because the same thing would happen, right? You get e to the t at the bottom and 1 plus v, which would cancel similarly. And hence show that that thing is greater than 0. Fine. So, wait. Okay, right, interesting. So, how do they want you to show this? It's only 3 marks. Is showing that it's increasing enough? Is that what they want? I don't know. Let me write it out. So what they want, the expression that they're concerned about is v of capital T minus k plus v of capital T plus k. which is, if I plug the expressions in, I get e to the k minus 1 plus e to the minus k minus 1, which I can write as e to the k plus e to the minus k minus 2, I guess. And they want you to show that this thing is always greater than 0, greater than or equal to 0. Which I'm not entirely sure what they want you to do. Is it to do with derivatives? Andrew.
Mm-hmm.
We're supposed to show that this thing is always greater than or equal to 0. Which, I mean, you can kind of see this by eye. I don't want to say by eye, that sounds mean.
All right, so your version of seeing it by eyes, my version of a purpose staring. Okay. What are we trying to do?
You need to show that this expression is greater than or equal to 0 for all k.
Okay. Oh, I remember seeing this. Can you complete the square?
Complete the square?
Multiply. All right. It's e to the k times e to the negative k. That's 1, right?
Sure. Oh, so you mean like find where this is equal to 0 and then show it doesn't?
So essentially, the expression you have there, that's basically e to the k minus e to the negative k squared. I'm going to write down.
I have no idea what you just said.
Okay, so e to the negative k.
Oh, I see what you mean. That's clever.
Yeah.
Wow. Okay.
No, I
This
know
is-
this because I have seen the marks give this question before.
That's
Like,
kind of
no chance on earth I would be able to come up with this on the spot.
That's kind of stupid to expect to come up with on the spot, though.
I know, like, anyway, but it's
That is
that's
ridiculous.
the great boundaries, though. So what is happening? This should be a minus negative k. It's weird. Here we go to 0. For O, K, and mat. Doesn't matter. Mat BB R.
That is ridiculous. I would like. I mean, I would not have thought of that. Anyway, that's this question done, I think. Does anyone have questions regarding this? Any of the points here? You can also take the derivative. Yeah, that's what I was thinking. Because, like, my initial approach, if I was to attempt this question and I was in the dark, I know that this thing, first of all, this is an even function. Because, I mean, you can kind of see by eye that this is an even function in k, right? If you sub in k for minus k, you get the same thing. And the next thing to note is that when you plug in k equals 0, you get precisely 0. And from that point on, if you take the derivative of this and show that that is always greater than 0 or greater than equal to 0, then you show that the function is always increasing for k is greater than 0, which means that it won't go below 0.
A more formal proof would be using AMCM inequality. That would definitely work.
Andrew? But why? What? How? Here?
Yeah.
for
I'm not
what?
kidding. That would work.
How? What are you talking about?
proving the inequalities, right? We want to show that it is greater than 0. So I'm just going to prove that e to the k plus e to the negative k, that'll be greater or equal to 2.
Oh, for fuck's sake. Okay, I see. That's ridiculous. Alright.
This, all right, that we really should have made this a separate part instead
Yeah,
of
I would not have
making
thought
it
about that either. That's also ridiculous. This was 3 marks. This last part was 3 marks.
Yeah, so as usual, as I usually say,
Okay, anyway.
cut your loss.
What's the next question, Andrew?
I collated the questions so like half an hour ago. So, all right, voila.
Oh, okay, great. Thanks. Oh my gosh.
Yes, we have quite a backlog of questions.
What the fuck is this? I don't want to do this integral.
All right, I can take it.
Yeah, please.
So
That looks like it's some formula booklet shit, which I won't know.
7 marks, M14. M14. Hold up, I should have a similar report for this.
Okay, hold on. Could you please
Yes.
teach us some math symbols and phrases that we might use or see? I don't quite know how to answer that.
This is definitely not IB. This is just the way I was brought. But no, like seriously, like these are the things that I was taught back when I was in middle school. But you will normally see this in uni, not in IB. So we are talking for O. Oh, sorry, this is for some, or they exist. This is for O. And that's all you need to know. So if I'm saying this implies that for O real values of X. While the first line, let's say I put there exists a value of X between A and B. This is, of course, not IB. Anyway, where were we? Where's the integral again? Voila. Okay. So X equals a secant of theta, and you want to show that this mass is equal to that mass. The best part is that you're given the answer. The bad part is that usually everyone skips this. I can't double check what is written on the exam report, though I wouldn't be surprised if it is not very optimistic. This is, hold up, this is M14, right? Paper 1 times on 2. Okay. So yeah, okay. So essentially, people mess it up as expected. So let's start. You are given a substitution. We call this a trigonometric substitution.
Yeah, but there's no way you're meant to come up with that on your own, right? Like there's
Oh yeah,
usually...
they will have to give.
Yeah, okay.
They will have to give you a substitution if it is not, you know, that's
They always
classic.
give you trig substitutions. Like surely.
I mean, if they hate you, they can give you a trig sub. That's what you
No,
do
but
with
need to do. You need to replace the upper bound, which is 2a in that integral. You need to replace the lower bound, which is a root 2. And then you need to replace like x and whatnot with the stuff that you did. So what Andrew did first is, like, if you want to find out where a times root 2 equals a sec theta, that's what you need to do to get the corresponding value of theta for the lower bound, right? So that's what Andrew did first. The second thing he did is found out where it equals. Okay, I'm hoping that was all clear now. I think you can keep going, Andrew.
Alrighty, so we found the bounds. We replace everything in terms of theta. That's when we start simplifying things. So now we're down to this integral here, which you should know how to solve by now, I hope. If you remember double angle identities, go back to my session. So now just gotta integrate. 1 sine of 2 theta over 4 plus theta over 2. And now it's just gotta plug in the bounds. That's gonna be sine of 2 pi over 3 over 4. Wait, no, that's stupid. Never mind. Sine of 2 pi over 3, that's going to be root 3 over 2 over 4, plus pi over 6 minus 1 over 4 minus pi over 4. So that would give you something like that. What's the final answer again? I don't know if I mess up somewhere. That's a problem. From a root 2 to a, okay. 3 root 3 plus pi minus 6. Hold up. Where did I go wrong?
Wait, why are you wrong?
X equals 8 secant. Okay.
Oh, right, because you have the thing there.
Dx is a secant.
Actually,
Yeah.
scroll down a bit. I think you missed a factor of a. So you have the a squared sec squared theta times a tan theta, right? In the denominator?
Oh, yep. Thank you.
No problem.
This is bound to happen every single time. Cube. Okay. What else? 3 root 3 plus pi over. Hold up. This.
Wait,
Yeah.
what do you meant to get as the answer? You need a factor of 24, right? Or something.
Yeah.
Hmm.
Cos, wait, hold up. Secant, that's cos, alright, cos of 2 theta, that's 2 cos squared minus 1. So flip, divide, integrate. That should be that. That's all good. Oh! How about knack? Okay. There we go.
Yeah, there you go. Yeah.
So plus pi over 24. And now we just gotta write everything back to.
Okay. Okay, let's.
Yeah.
The linear algebra question has come up again, so I'll do that one, I think, on my note, on my Paint file, and then I'll probably head off
Okay.
after you finish with this.
That's fair. Plus pi. Yeah, or you can just write nicely. Because it's a question after all. As required. Give him an extra box at the very end, or you can just write QED. Up to you.
Nice.
Where are we again? And no, we cannot just do questions out of nowhere because we have an entire backlog of questions to get through. And I don't think we have time to get through everything, unfortunately.
Yeah, I mean, the question that was just posted, I think, has come up before. Like, I remember seeing it early on.
So, wait, this guy. Oh.
Should I screen share?
Sure. You want to take it?
Mm-hmm.
Stop sharing real quick. There we go.
Okay. So, let's see. Consider the points A, B, and C. Write down AB and AC. So this is the same thing as before.
Even that AB and okay.
Will just be the vector to B, which is K minus 2.
Oh,
minus.
I see when they want to do this.
I'm not there yet, but I'll get there. So this is going to be K minus 1, minus 4, minus 2, and then similarly AC is the same process, right? So you have 5, 0, 2, minus 1, 2, 3, which is just 4, minus 2, minus 1. Simple enough. Easy 2 marks. Given the points A, B, and C lie in a straight line, show that K equals 9. Interesting. So this is 1 mark, so this needs to be easy. What's the strategy here? Oh, you have AB and AC. No wonder. Okay, so if they lie on a straight line, then these two have to be collinear, right? So you need so for part B, you know that 4 minus 2 minus 1 must be equal to, like, let's just say some factor C times K minus 1 minus 4 minus 2. From these two components, you can kind of tell that this has to be 2, which then gives you 4 is equal to 2 times K minus 1. So just solve for k minus 1 equals 2, k equals 3. Or, I did that wrong. Is it a half? It's a half. So k equals 8, k minus 1 equals 8, k equals 9. That should be that for part B. Yeah, I made a silly mistake. Don't worry about it. Okay, let's look at part C, because part C is 10 marks, and this is... What's happening here? For k equals 9, let L1 be the line passing through A, B, and C. Find the vector equation for L1, and then there's a line L2, which they've given you the equation for. Show that the lines L1 and L2 are skew. Right. So let's find L1. The vector equation for L1 should be relatively okay. So what you want is, let me think. You need, so you have AB, or AC actually. So this will give you a direction vector. And you can just take like A as a position vector. So you'll get, let's take 1, 2, 3, plus, and then you want some parameter lambda times the direction vector, which we can just take as 4 minus 2 minus 1. I think that's the vector equation, in which case that should be sufficient. Right? I'm pretty sure that's what's called the vector equation of a line. Anyway, so, okay, line L2 has an equation that looks like that. Show that the lines are skew. I think you can... There's a way to convert this form into a vector form. Do you remember what that is, Andrew?
There's a way to convert that guy to a vector form.
Because they've given it in this form, and I remember that these numbers mean something. I don't remember what.
That's the direction vector of a line.
Which one is the direction vector?
The 2, 3, and 1.
Oh,
Basically,
okay.
you just set it equal to a parameter, call it t or something.
And then wait. Then what's 1, 0?
That's the point.
Is that the position vector?
Yes, essentially.
Okay, got it. Okay, so this is for L1, and then for L2, let's call this R1 and R2. Let's do, so this would be 1, 0, minus 1, I think, or no. This would be 2, 3, minus 1, right, Andrew? And then this would be 1, 0, minus 1.
2, 3, minus 1. Wait, hold up. Z minus 1 over minus 1.
Oh wait, no, this would be plus 1.
Yeah, that should be a plus 1. Yes.
Okay, good. Now I should just show that these are skew, which I don't remember how to do actually.
So essentially, you want to show that 2 of the coordinates are the same, but the third will be different.
But the what will be different, sorry?
So after 3 coordinates, 2 will be the same, 1 will be different. So you will pretend, let's say, that they intersect. The first 2, let's say x and y coordinates, right? You equate the 2. Also, you should have used a different letter instead of lambda, because we're going to solve it simultaneously.
Yeah. But wait. If they're skew, they are also not intersecting, right? Or am I remembering wrong?
Yes, but 2 of the coordinates will be the same. So think of it as they'll be intersecting if they are on the same plane, except they're not on the same plane.
Okay, sure. Oh, I didn't even label it.
So I'm gonna quickly sketch it out for those of you who are a bit confused. Let's say you have L1, L2.
Wait, are you writing stuff? Do you want to screen share?
No. I'm just gonna
Okay.
put it up real quick. Intersecting. Skew. Would intersect it, but not on the same plane.
I mean, I have a method for this, Andrew, but I don't know if it's kind of bullshit.
Yeah, I had to brush up on vectors because my students just had vectors. So
No, but can I explain what my method is?
go for it.
So my method is to find the vector that is so my method would be to take the cross product of the two direction vectors and then dot a position on each line with that and show that they're different values.
Wait, say it again.
So I take a cross product
Uh-huh.
of the two thingies, right?
Of the two
direction vectors. Yeah.
Okay.
And so that'll give me a vector that's normal to both lines.
Correct.
And then if I take a dot product of some position on that line, so if I just take like the position vector of each, dot it with the normal vector, if I get different vectors, then if I get different values, then I've shown that it's skewed.
Hold up. Would that make sense? If you take a different point, okay, on the line.
Because Andrew, think about it like this: if they did intersect,
yeah,
then you would get the same value, right?
Not necessarily. Wait, well, yeah. Sorry, yeah.
Yeah. So if you do this process and show that you get different values, that means they don't intersect, and they're also like they obviously have different pointing direction vectors, so you get that they're skew lines, like they must be. Does that make sense? If that makes sense to you, then I'll try and explain it.
No. All right. What you're saying so far makes all right. So the first part that if you get, hold up, if you're intersecting, you would get the same value for the dot product. That makes sense.
Mm-hmm.
But for the second part, that's why I'm a little unsure with that.
Let me draw it out. So I'll try and draw it out. So you have like a line that goes like this, for example, and a line that goes like that, right? Which are skew. And say this is like a
skew.
Perpendicular direction.
What do you mean skew in a sense?
What do you mean?
No, are they intersecting?
No, like let me just draw the planes that these.
Yeah, that would really help.
Right?
Yeah.
Like suppose they exist in these two planes, these two lines that I've drawn. Right?
Okay.
And then you can draw like a normal vector to these planes. These planes are parallel. So suppose you can draw a normal vector to these planes that passes through both lines, right?
Yes.
If you take if you take the cross product of like this one's direction vector and this one's direction vector, right? If I
yeah, that would give you a normal of both planes. Yes, that makes sense.
Yeah. So this will give you a normal vector, right? Which will point like in this direction. So if I then take if I just take like one of the points, like if I just take the position vector, which is somewhere on this line, like somewhere on this line, and I dot it with this, if I get different values, then I know that they're on different planes, and so they're skew lines.
and you get different values. Oh, all right. I see what you mean. Okay, yeah, I see what you mean. Yeah,
Okay.
yeah. Because
Did that make
if they are on the same line, then when you dot it, it should be 0, right?
yeah, like if they are intersecting, then you'll get the same value
Yeah.
from this dot product.
Yes, if they're intersecting, aka the two lines are on the same plane, aka the dot product will be 0.
Yeah. Okay. Did that make sense to literally anyone other than Andrew? Or should I repeat what I just said?
Thank you for being honest.
Is the no for whether it made sense or whether I should repeat it? Repeat it. Okay, cool. So right. So let's let me draw this in. Let me give myself some space. So suppose I have the origin here, and let me give myself like a large canvas. So suppose I have two lines that are defined here, right? Let's say that I have a line that has this position vector and this direction vector or something. Like let's draw it like this actually. And then I have another line that's like over here maybe, and it points in like that direction or something. I don't know. So let's say that these lines exist within these parallel planes. So this is the line for the red. This is the red line, and then similarly, this point lies in like this plane, right? These lines are then skew, right? Just by like how skew lines are defined. They're not. They're like non-intersecting, non-parallel lines or whatever in 3D. Great. I did not take visual arts, but that's a great compliment. Thank you. So now that you have, so there's two parallel planes that these lines exist in. If only you had the normal vector for these planes, because they have the same normal vector, right? They're parallel planes. If you had the normal vector, this problem would be very easy, right? Because if I know this normal vector, I just take the dot product of the normal vector with these points, and if they give me different answers, I know they lie on different planes. Does that make sense? Because think about how a plane is defined. One of the definitions of a plane is a normal vector times whatever point on the plane is equal to some constant value d. So if d is different, then I know that they're part of distinct planes. So, sorry, let me clarify. It is perpendicular to the direction vectors. What I'm taking the dot product with respect to is the position vectors. So this and this. Remember, position vectors go from the origin. So if I take the position vectors of the red and blue points, dot that with the normal vector, then there's two possibilities, right? Either they're the same, which means they lie on the same plane and they intersect, or they lie on different planes, which means distinct parallel planes, so they don't intersect. So my point is, if you have the normal vector, this problem becomes easy. So the question is, how do I find the normal vector? And the answer is, does someone know? Yeah, correct. It's a cross product. I don't think you can do that, no, because like suppose they did share a plane, right? Suppose that the red and blue lines were actually both on this plane. Then they would be non-parallel, but they would also have an intersection. So you do need to go through this process. Okay, so let's compute this normal vector. Let's move this down. So what I need to do here, I have my two direction vectors. So I need to take the dot product, cross product of these. So as before, let's write this out. -2, -1, cross 2, 3, -1. And if you just use the formula in your formula booklet or the method that I said, you should get 2 minus -3, -2 -4, 12 minus -4. Wait. I think that's correct. So this is what? 5, 2, 16. And this is my n. So now what I need is I just need 2 points on the line, right? And I have those 2 points, right? These are this and this. So let's compute this. So let's call this d1 is equal to n dotted with I'll just call this p1 and p2, where p is for position vectors. So this is going to be 5 to 16 dotted with 1, 2, 3. And this is equal to 5 plus 4 plus that. 9 plus 48. 48 plus 9 is what, 57? And then D2 is going to be same thing, but with the other position vector. So let's do 5 to 16 dotted with 1, 0, 1. That's quite a bit easier. So this is going to be 5 plus 16, which is 21, which is of course notably not equal to 57. Therefore, the lines are skew. Now, okay, just quickly, for those of you that are wondering how to find the distance between skew lines, because this is kind of relevant, right? The distance between skew lines is the distance between these two planes, right? The way you find this is also using the normal vector. So suppose I want the distance between these two skew lines. I have this n dot, I have this d1 and d2 value, right? This thing is just going to be equal to d2 minus, or sorry, d1, I guess in this case, minus d2 divided by the absolute value of the normal vector. Because remember, dot product scales with the magnitude of the vector, so you need to divide by the magnitude of n, but you have the difference between the planes already. And again, skew lines exist in like distinct planes, right? So you just need to find the distance between that. Okay, I also do need to go. So Andrew, if you're still here, it's up to you if you want to continue or take over, or if you want to end the session now.
So where are we at so far? So wait, Okay, so
Oh,
you
sorry. Let me quickly clarify. So the reason
Yeah.
we're taking the cross product is, you know that uh both both direction vectors share the same direction of plane, if that makes sense. Like, this plane and this plane are parallel planes, and this vector and this vector lie along these planes. So if you imagine just moving this vector here, right? Like, just imagine just transporting it. This gives you a vector along the plane. So if you take the cross product, it makes sense that you would get a normal of that plane as a result. I'm pretty proud of this drawing, actually. Okay, anyway, it's up to you now, Andrew. I'm gonna head. I
what's
will
left
I
in
will
the
upload.
question, or is this question done?
Yeah, should be done. I'll save it and upload this, but I'm gonna head now.
Okay, I don't know how much more I could do. So maybe I can continue. Maybe I can do for the next, I don't know, 15, half an hour, and then I also got to
Yeah,
study
okay,
because
okay.
I'm in finals.
All right. All right. Good
That's
luck, everyone. Good luck with your math exam, and remember, don't discuss stuff on this server. I don't want you all getting banned, so please wait until your discussion time is allowed. And best of luck. I'm sure you guys will do great. Bye bye.
Alrighty, so I will still take over for the next like half hour or so, hopefully. Obviously, we already admitted defeat. It's impossible to get through all the questions, but we'll do what we can. So, you can still hear me, right? So, all right, so creative covered parts A to C. I'm pretty sure. Did he do part D? I don't think so, eh? So A, that's going to be 1, 2, and 3. B, that's going to be K, -2 and 1. C, that's going to be 5, 0, and 2. Though, to be fair, if you were here earlier, this question is very similar to the one we did on distances. So, in parts C, we were saying that, okay, these 3 points form a line. And we're asked to find a distance between 2 skewed lines. I prefer to put it like this. Of course, people have different things. In part D, now we assume that they are not on the same line. But instead, they form a plane. And then you're asked to find the shortest distance between the origin and the plane. The shortest distance is always the perpendicular distance. So your job is, 1, what is the equation of the plane? 2, what is the intersection between the origin and the plane? Or you just need to find the and then you can find the distance. So step 1, how you find the equation of a plane? Wait, are we given what k is, or we have to find the coordinates of the point which is closest? Oh, okay, interesting. So, all right, we know A, B, and C are on the same plane. All right, basic stuff. So first off, find the cross product of these two. AB, we found to be k minus 1, negative 4, and negative 2. AC, we found it to be 4, negative 2, negative 1. Right? 5 plus 1, 0 minus 2, 2 minus 3. Yep, k minus 1, negative 2 minus 2, 1 minus 3. Okay. And now we have to find the cross products of the two. Go for the first column. That will give you negative 4, negative 1, minus negative 2 times negative 2. Second coordinates, go for the second column. 4 times negative 2 minus k minus 1, negative 1. Third coordinates, k minus 1 times negative 2 minus 4 times negative 4. Or 4 minus 4 minus 8 plus k plus 1. No, sorry, plus k minus 1. Negative 2k plus 2 plus 16. Or 0, k minus 9, negative 2k plus 18. Okay. So this is very convenient, I would say. Because we can just say that the normal vector is going to be 0, 1, and negative 2. If we divide everything by k minus 9. Which we're allowed to do because k is not 9. So we found a normal for plane. We know a point on the plane. We know A, 1, 2, and 3 lies on the plane. The equation of a plane is therefore x plus 2y plus z is equal to d. We know what n is. Sorry. Oh, my bad. 0x plus y minus 2z is equal to d. We also know that A lies on the plane, so 0 times 1 plus 2 minus 2 times 3, that's equal to d, for d is negative 4. Therefore, equation of a plane is this guy. I think it should be pretty straightforward. So that's the first part. We found the equation of a plane. Part 2, what is the distance? So now we've got to find the intersection between the origin and the plane itself. Let's call the intersection I. We know that OI is perpendicular to the plane. So this implies that the direction vector of a line, OI, is the same thing as the normal vector to the plane for n. The origin has, of course, 0, 0, 0 plus t times normal vector, the equation of a line, OI, are equal this. The normal vector, the direction vector of a line OI, that's the same thing as the normal vector to the plane, or 0, negative 4, 0, 1, negative 2. Now we have to find the intersection of OI and the plane. So replace y with t and replace z with negative 2t. We have t equals negative 4 over 5. All right. Last step. What is the this? Oh, wait, no. We need to find the coordinates. Oh, now we're mostly done then. Because if t is negative 4 over 5, then OI is therefore O -4/5, and 8/5. Done. We make a line position factor. Not really. Yes, because it's perpendicular. Oh, sorry. I is here. O is there. The direction factor, OI, that's perpendicular to the plane. The normal, by definition, is perpendicular to the plane. So we can just take the normal factor as our direction factor of the line. All right. What other question do we have? People are dropping out. Okay. Any questions we want to go over? Otherwise, I'm just going to continue with the list of questions we have here. See, the problem is that I don't know if these soldiers are still with us. So I don't know if it's worth doing the questions. Okay. Okay, no. So basically, we have a parabola, another parabola, another line. We know this is x equals 0. We know this parabola. We also know this parabola. And y equals m. So visually, how does it look like? The entire question is built around the idea that you have a line and you start moving up, 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 up until you reach the required area. So how do we know where to stop? Let's say if we go here, let's say we go all the way there, for instance. If this area between there and there is all right. Sorry. First off, we're gonna stop here. Would it be more than less than our required area? If it's not enough, let's go more. Over there. Is it enough? If it's not enough, move on even more. So that's the logic behind it. The way you would set up this question is that Archie wouldn't bonk you. Is that you really gotta show that you know what we're doing here. So you might want to find the intersection of all these lines. aka, first off, where's this point? So a quick check would give you that this point has x coordinate of 5. And you want to do the integral from 0 to 5 of x plus 5 minus x minus 2x minus 5 dx. Remember, this is a calculator question. You are allowed to just punch out your final answer. And I think I have the answer with me right now. So that would be, hold up, where is it? Question 7. Okay. So this guy would give you 275 over 6. This is less than what we asked to find. Basically, we want to find what the intersection is between the first curve, sorry, the regular quadratic function with the line. We found that even when we go all the way to the intersection point up there, this entire area is 275 over 6. That's not enough, so we have to go up even more. The second question is, how far do we go up? Do we go up all the way there? Well, let's cross our fingers. Starting now, we're integrating with respect to y. The outer function, that's going to be 14 minus y minus 13 squared. The inner function, we got to cast this line in terms of x. So in terms of y. So x is equal to y minus 5. So lower bound is this guy. Sorry, the lower function. The lower bound is now the y coordinate of the part of intersection, or 10. And upper bound is going to be m. And this guy has to be a difference of the two areas. Unfortunately, I don't think there's much you could do apart from actually integrating this, because it has the m up there. So we're going to integrate. That will give you an equation in terms of m. From there, you can solve to get m equals 13. So, do we have any other questions? I don't know if I particularly fancy going over. Okay, last question of the day. So we have the weight that is released from the base. That's going to be a trigonometric functions. And you corrupt out the top. So I have zero clue. What A and B are. I don't. Sure, chicken noodle, but I don't want this to be recorded. I don't want to do it. I don't want to do induction. Feel free to DM me. Yes. Okay, there we go. H of t, that's A cos 7.8 t plus B. 0 less than t less than 10. Now you're given the entire graph. What else do you know? You know that the minimum height is 1. The maximum height is 1.8. All right, 1. Oh, sorry, part A. Find the period of the function. 2 pi over 7.8 seconds. That's going to be the period. So, sorry, 2 pi over 7.8. That would be 0.805 seconds. That's going to be the period. Part B. Minimum height 1 meter, maximum height 1.8. Midline B. That's going to be the average over 2. The amplitude is going to be the difference of the top and the midline. I know I went through this extremely fast. So this is the minimum is 1, maximum 1.8. Midline is basically it all hovers around this middle point. That's going to be the average over 2. Amplitude is the distance between the top, between the maximum and the midline, or between the minimum and the midline, depending on how you like it. C. Find the number of times that the weight reaches its maximum height in the first 5 seconds of its motion. Okay. Maximum height. So basically, we are trying to solve 0.4. So 0.4 cos 7.8 t plus 1.4 equals 1.8 for 0 less than t less than 5. Obviously, this is a calculator question. So cos of 7.8 t is equal to 1. 7.8 t. That's going to be k times 2 pi. T is therefore k times 2 pi over 7.8. And now we're going to try for different values of k. So if k is 0, t is 0. If k is 1, t is 2 pi over 7.8. 0.805. If k is 2, double that. If k is 3, 4, 5, and 6. If k is 6, you will get 4.830, then get 5.635. 5 seconds is right between those two. So therefore, it will pass exactly 6 times. Oh, wait, no. Sorry. Wait. We start at negative, right? Yeah, we start at the bottom. Ooh, my bad. Because we start at the bottom, that A should be negative. because we start at the bottom. Just plug it in. If t is 0, at the start, we'll add negative 0.4 plus 1.4. That's gonna be... Wait, this makes sense. Hold up. At the maximum height, right? Yeah. Wait. Negative 0.4 plus 1.4 equals that. So the cosine is not this guy, it's actually negative 1. So therefore, that's going to be 2k plus 1 times pi. Sorry about that. And all these values are wrong. So if k is 1, we will get pi over 7.8. Then we get 3 pi over 7.8. Then we're going to get 5 pi until, I don't know, 13 pi. That'd be 5.5. Eleven pi, that's going to be... So the 5 pi intersection is right there. 5 seconds. So therefore, we pass the maximum point exactly 5 times. Wait, no. Oh no. It should be, sorry, it should still be 6 times. Because there are 6 different values of k that would satisfy this condition. Okay. C. Sorry, D. Find the first time at the base of the weight reaches the height of 1.5 meters. One, 1.8. We want to find where 1.5 is. Sounds like we have some end solve shenanigans going on. Solve for C. Take the first value. Part E. E is probably the most challenging part. A camera is set to take a picture of the weight at random time during the first 5 seconds of its motion. Find a probability that the height of the base of the weight is greater than 1.5 meter. Okay. How do we conceptualize this? At the bottom, let me go up. 2, 3, 4, 5, 6. We found that it will reach the maximum 6 times. So 0. Somewhere over here, maybe that'll be 5 seconds mark. And we want to find all the intervals at which it is above the 1.5 line. So first off, we gotta find my calculus is in degrees right now. 4. Okay. If negative 0.4 cos of this guy is equal to 0.1, this guy is equal to negative 0.25. So cos negative 0.25, that would be 1.823, or 2 pi minus that plus k2 pi. my god. 2 pi minus 1.833. All right, so for each interval, we found the two intersections. Basically, what we just found is that this point right there, that's point 0.333. That point right there, that's 0.5718. This is the same for every single period. So our job is, first off, where is that 5-second mark? 2, how many full intervals do we have? So at 5, that would be 1.29. So it should end somewhere over there or somewhere over there. Doesn't matter. But it still means that we will have a full 6 cycles. The probability is therefore, over the 5-second period, there are 6 full cycles where the object is above 1.5. And that should give you a final answer. The last question is the free testing. Any other questions? I will do one more before I call it a day. I don't know what to do the induction. Or show stop. I'm scared. All right. If no one has any question, then I think I should call it a night. Or because, well, I don't know. Yeah, I'm just gonna call it a day. So thanks for hanging out with me and Creative. Though he dipped a bit earlier.